R-CADT, Research Center for Advanced Decision Technologies is pleased to invite you to participate in the postgraduate level course. Oil and Gas Industries Enterprise-Wide Optimization, a different course in advanced optimization. The course covers the math modeling of the following process in O&G supply chain. Oil and gas artificial brains, oil exploration and exploitation, multimodal transportation of petroleum and petroleum products, petroleum and petroleum products transportation in pipelines, oil blending, transport, and trading, oil and biomass refining, distribution of refined products, blending of derivative products, natural gas supply chain, ETRM, energy trading and risk management, O&G Energy Efficiency, O&G state estimation, Kalman filtering, and O&G supply chains design under uncertainty and risk management. HI operates as a knowledge factory in artificial intelligence and advanced mathematical modeling, focusing on artificial business management, autonomous AI that guarantees objective decisions. Artificial brains, integrates organizational decisions based on neuroscience. Enterprise-wide optimization systems, EWOS, customized AI that integrates multi-problem model systems, and high-complexity mathematical models, traditional models that are part of our artificial brains. The course covers the following artificial intelligence methodologies: predictive artificial intelligence, machine learning, framework, advanced probabilistic models, neural networks, support vector machine, and hybrid methods, Kalman filter, decision-making artificial intelligence, framework, economics and optimization, large-scale optimization methodologies, mathematical programming with equilibrium constraints, parallel optimization, real-time autonomous distributed optimization, and artificial brains. Independent testimony. I am proud to share that I have successfully completed a diploma program from Hypothalamus AI focused on leveraging mathematical modeling and AI for strategic decision-making in the oil and gas sector. I deeply appreciate Jesus Velasquez Bermudez's dedication and effort in delivering the training. I am confident the knowledge gained will greatly benefit my professional endeavors. Chemical Engineer, Staff Optimization Engineer, Saudi Aramco, Total Refining and Petrochemical Company, SATORP. The instructor of the course is Engineer Jesus Maria Velasquez Bermudez, Ph.D., who, in 2024, won the Artificial Intelligence Award of the Industrial Engineering and Operations Management Society, IEOM. Hypothalamus Artificial Intelligence brings real-world oil and gas business optimization practice to academia to teach enterprise-wide optimization systems implementation. HI has established technology and commercial agreements with organizations committed to highly complex mathematical modeling, such as GAMS, General Algebraic Modeling System. GAMS supports HI courses by providing students with temporary licenses to use during the course. Then, the material that HI delivers in GAMS programs may be used by students. The support also includes 1 or 2 lectures given by GAMS to present its optimization technologies. R-CADT, Research Center for Advanced Decision Technologies, is a division of Hypothalamus Artificial Intelligence Incorporated, USA, oriented to research, technological development and innovation, RAND+I, in high-complexity mathematical modeling, with an emphasis on optimization, whose mission is to bring its benefits to humanity, which involves enable professionals to successfully apply optimization technologies in their organizations, and be entrepreneurs and mentors of new companies, spin-offs, that bring the benefits of optimization technology to society. Currently, the central topic of RCADT's research is augmented artificial intelligence and more specifically the artificial brains. To fulfill its mission, RCADT has created a set of courses in advanced mathematical modeling that are aimed at supporting professionals interested in receiving applied training, at a cutting-edge level, based on the experience capitalized on more than 50 years executing engineering projects and development of analytical software. Parallel thinking. Like paper-based math, sequential math for single-processor computers is dead. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics are autonomous, parallel, and distributed. Objective and structure. The material covered in the course covers two broad areas of applied mathematical programming: oil and gas systems and markets modeling, and implementation of O&G enterprise-wide optimization systems. Both topics are addressed from High's vision of multi-problem mathematical models, in which the development of computer solutions is oriented from the programming of algebraic formulas to the structuring of models, integrating the problems that make it up, as a Lego game. The student will learn about the main technologies for the implementation of mathematical programming algorithms and will learn to see them from this point of view, typical of Industry 4.0. But it is not a specialized course in algorithm implementation. Structure. The course is based on specialized academic activities aimed at training the participant in the main mathematical problems that must be solved in the strategic and tactical planning, operations scheduling, and process control of oil and gas systems and markets. The basic unit of the course is the virtual session with an average duration of 90 minutes each. To do this, the classes are recorded on videos, by artificial intelligence. The classes are grouped into modules that cover the petroleum product supply chain. After watching the videos, students must attend face-to-face virtual sessions, in which the course teacher will clarify existing doubts. 2 conversations are held monthly. Students should submit their questions in advance. Objective. The course program is aimed at training professionals, at the graduate level, in applied mathematical modeling, taking advantage of the instructor's 50 years of experience in the area. The course is aimed at professionals who want to become applied professionals in highly complex mathematical modeling, with emphasis on the use of methodologies and technologies for the solution of large-scale optimization problems. It is also useful for graduate students who are pursuing theses or research projects related to optimization applied to complex problems. It encompasses the teaching of the theoretical foundations of large-scale optimization, with an emphasis on atomizing problems to solve them in parallel computers or computer networks. The objective is to present the integrated vision of real-time distributed optimization, RTDO, as the mathematical way to model the cyber-physical systems of Industry 4.0. It is characterized by the integration of multiple algorithms that continuously cooperate to solve the problems of a multi-agent system, independently using the parallel computers of the agents and sharing information to cooperatively achieve an optimal solution. This theory is constructed using the fundamental theories of partitioning and problem decomposition, Benders, Lagrange, Dantzig-Wolff, cross-decomposition, and others. By the end of the course, the participant should be aware that future mathematical models will solve problems of more than a billion variables, or perhaps trillions. The course covers the following topics: next-generation analytics and advanced computing, parallel thinking for the partitioning and decomposition of complex systems, oil and gas industries, enterprise-wide optimization, specifically Bender's partition theory, Lagrangian relaxation, Dantzig-Wolff decomposition, cross-decomposition, subrogate programming, and asynchronous parallel optimization sliding optimization. Advanced concepts of artificial brains, and implementation of oil and gas industries, enterprise-wide optimization in the real world. For the different methodologies, examples of real-world problems and computer programs are presented, so that the student understands the application of what is taught. Aimed at professionals, engineers, data scientists, mathematicians, physicists, consultants, economists, software developers, etc., who require and/or wish to become experts in mathematical modeling, acquiring the knowledge to handle the state-of-the-art parallel and distributed analytical level, using mathematical programming intensively. This continuous training program strengthens the analytical skills and professional criteria of the participants, so that they can exercise, share and/or supervise, with propriety, the professional functions of this branch of knowledge, in accordance with the state-of-the-art of the methodologies and technologies that support the digital transformation of companies. The course is aimed entirely at the oil and gas sector, therefore, all the material will deal with this industry and other energy-related businesses. Obviously, those who get the most out of the course are mathematical modelers experts in the oil and gas industry. But executives, managers and engineers in the industry are trained to understand the present and future of artificial intelligence for decision-making, to structure and participate in projects of this science of the future. Artificial intelligence is accessible to everyone, but understanding its true scope requires proper training. AI can teach knowledge, but it cannot create understanding. This is the responsibility of the student. Duration. The total duration of the course is 50 hours of training, divided into approximately 25 sessions of 90 minutes each session. The course is designed for the student to take 1 or 2 classes each week. However, the speed at which the course is carried out depends on the student. There is no class calendar. Start date of the virtual course. At any time. Classes are recorded using artificial intelligence. All videos are offered in English, and some of them in Spanish. Being on YouTube, all videos can be read in another language using the subtitle service, CC. Every 2 weeks, a discussion on a specific topic is held, which all students are welcome to attend. Material. The student receives a book in editing, draft version, with the material seen in the course, documents drafted especially for each of the sessions for some classes, the source codes of the mathematical models associated with the class will be distributed. Permanent access to all videos of the recordings of the class sessions. PDF copy of the presentations used to record the videos. Access to a paper's digital library with specialized documents on the topics covered in the course. Project. If the student wishes to carry out an advanced analytics project during the course, they can indicate this to the scientific director. If accepted, an advisory program on the project would be jointly defined between the R-CADT and the student. Artificial Hypothalamus Mathematical Programming 4.0 Autonomous Real-Time Distributed Optimization. Artificial entrepreneurial brains rely on the development of parallel thinking, when a complex system must be analyzed. And reality is complex. The diagram presents the simultaneous evolution of 3 fundamental aspects in Industry 4.0. Information technologies, analytics and mathematics. The instructor of the course is Engineer Jesus Maria Velasquez Bermudez, Ph.D. Who is the creator of the artificial hypothalamus, the result of the integration of mathematical programming with artificial intelligence based on neuroscience. Most of the things and processes that humans use have been totally affected by technology, which has opened up to the human imagination producing previously unsuspected results. Mathematical modeling should not escape this process, starting from discovering the mathematical foundations that serve to establish the laws that govern physical, industrial, economic, biological, health, and social laws, and with them build mathematical models, and increasingly powerful calculation algorithms. Nowadays all knowledge and technology are available to develop a higher-level artificial intelligence, which emulates human intelligence in any type of human organization, and can be called the artificial hypothalamus of the organization. The power of today's technology is not in the mathematical calculations it allows to be performed, it is in the mathematical calculations we can imagine we can perform. The founder and chief scientist of HA is the creator of Optex, his most important technological work. The video. The history of Optex, the optimization expert system. From the simplex method to multi-problem models, Optex expertise meets artificial brains, moving toward mathematics-based general artificial intelligence. And the article Optex, where optimization expertise meets artificial brains. They present the history of Optex, which is the professional history of Jesus Velasquez Bermudez. Jesus Velasquez Bermudez in 1990 created Optex, Optimization Expert System, an optimization platform that was developed with a new vision of mathematical programming. To date, Optex has completed 34 years of continuous growth and updating. Proof of this is the current R+D plan that HI is developing to incorporate the latest achievements of AI, such as ChatGPT, to facilitate the dissemination of mathematical modeling in Industry 4.0, taking it to the level of people not specialized in the subject. You can find more information about Optex in the LinkedIn post. From simplex method to mathematics-based artificial general intelligence. The founder of HI has focused his scientific research on the development and incorporation of parallel optimization algorithms to Optex. The algorithms created are Primal Dual Subrogate Algorithm, PDS, Multi-level Bender's partition, MBP. Generalized stochastic dual dynamic programming, GSDDP. Multi-Bender's decomposition, MBD, and sliding optimization. These algorithms, and others more existing in the literature, support the implementation of artificial brains. Success case, China National Petroleum Corporation. The purpose of this case is for course participants to understand the economic losses that are avoided if artificial intelligence models are used for decision making. The function of every organization is to produce wealth for all its owners, and this is not obtained only with goodwill. The paper Operations Research Enables Better Planning of Natural Gas presents the use of mathematical optimization models for pipeline planning. China's natural gas consumption has nearly doubled in the past 5 years. To better meet demand, the China National Petroleum Corporation, CNPC, China's largest producer and supplier of oil and natural gas, partnered with researchers from the University of California in Berkeley, and Tsinghua University in Beijing to apply operations research to develop and implement new software to help CNPC to improve the management of its pipeline network. Previously, all pipeline production and construction planning for CNPC, which controls 72% of the country's natural gas resources and 70% of its pipeline network, was done by traditional methods using spreadsheets. However, due to the increasing size and complexity of the network, the use of the traditional method resulted in excessive costs and wasted resources. Since implementing the new software, which uses a 3-stage convex relaxation method and iterative piecewise linear approximation methods, in late 2014, CNPC has obtained approximately $530 million of American dollars in increased earnings, 2015 to 2017. In addition, the resulting increase in the efficiency of the existing pipeline network allowed the company to postpone the addition of new pipes, leading to an official budget reduction of more than $20 billion of American dollars in construction costs for the following 5 years. The image present the algebraic formulation of the natural gas pipeline transmission model. Without fear of being wrong, it can be said that mathematical optimization models are the goose that lays the golden eggs of China National Petroleum Corporation. Oil and gas industries. Enterprise-wide optimization and advanced analytics solutions. The interested party can watch the webinar, in Spanish, live. Supply oil chain optimization. Advanced analytics solutions. To have an overview of mathematical modeling in the O&G sector. The oil industry includes global processes of exploration, extraction, refining, transportation and marketing of petroleum products. The largest volume products in the industry are fuels, natural gas, fuel oil, and gasoline. However, petroleum is the raw material for many chemicals, including pharmaceuticals, solvents, fertilizers, pesticides and plastics. The table, elaborated by IBM, shows a resume of the optimization solutions for oil and gas enterprises. At the origin of mathematical models in computers, starting in 1947, decision support systems, which represent the optimization system of an owned company, have been visualized as composed of multiple mathematical problems, one for each line of the table, which are operated individually and communicated sequentially by humans. This way of operating produces solutions close to the optimal, but not optimal, because they generally have no feedback. The current technological revolution completely changes this approach. Today, O&G's business optimization can be visualized as a single supermodel, composed of submodels, which in turn are made up of mathematical problems, one for each line of the table, which are solved by running in parallel, autonomously, communicating with each other, and managed by a mathematical artificial intelligence, produced by a generative artificial intelligence. Hierarchical coordination of planning tools. It is traditional to organize decisions hierarchically into strategic, tactical and operational. The operational decisions are divided into the scheduling and advanced optimal control. However, due to the technological progress generated by Industry 4.0, mainly in relation to smart metering systems, nowadays we can talk about a new type of online optimization modeling, real-time distributed optimization. From the point of view of mathematical modeling, hierarchical levels are intertwined and coordinated through the boundary conditions in time, and common modeling that can be shared. The modeling strategy of HI is that all models of a decision support system can communicate with each other. Large-scale optimization and artificial brains. One of the fundamental ideas of the artificial brain is the atomization of the system, bottom-up approach, to integrate multiple mathematical models, using the framework of large-scale optimization methodologies, like multi-level Bender's theory, and Lagrangian relaxation. The same system can be organized hierarchically from multiple points of view. Because they are the same system, all these views must be equivalent. That is, in a non-degenerate optimization model, they have the same solution. The image presents the hierarchy from the point of view of regionalization. Considering the vision of large-scale optimization, which can have multiple points of view, HI developed the multi-Bender's decomposition (MBD) algorithm to emulate the coordination of multiple points of view, just as the human brain does, following the studies carried out by Jeff Hawkins, summarized in his book, 1,000 Brains. On the other hand, if other intelligent structures are studied, different from the human brain, it can be concluded that this structure is not necessarily the best, and that there are alternatives in nature that can be artificially implemented. An example is the octopus, which has 9 brains, 3 hearts, and 2 memory systems, which it uses to control each of its 8 limbs independently, allowing it to move nimbly and react quickly to any threat. In addition, it has a central brain that hierarchically coordinates the secondary brains. This is one case, among several, of beings with multiple brains. It is evident that the structure of cephalopods is reproduced in human organizations, so a multi-brain artificial brain can be useful. In the global nature of modern companies, which must fulfill planning functions at different levels of their regional distribution for industrial, financial, and commercial operations, a multi-brain artificial brain structure is useful, as in cephalopods. This hierarchical vision of the system can be converted into a different, but equivalent, approach. A vision focused on the mathematical neurons, which form a network connected according to the map established in an artificial cerebral cortex, forming what would be an artificial hypothalamus, which feeds its decisions from an artificial hippocampus, which stores the history of the system, in terms of math models, and executions of these models. Like the human brain, the artificial brain is made up of the following artificial components. Neocortex acts as an organizer of the connectivity of mathematical artificial neurons. Hypothalamus, it is the central processor that coordinates all the models included in an artificial brain, and hippocampus, it is the memory of the brain that stores the history of what is happening in terms of mathematical model runs. It is coordinated by a traditional artificial net. The most important planning function in a company may be integrated business planning, IBP, which integrates, at least, 3 areas: finance, marketing, and sales, and production. The IBP model can be looked at from 3 points of view. 3 independent models, which are integrated through a process in which the input of one model is the output of another. A monolithic model that integrates the 3 models, and that is run periodically, and an artificial hypothalamus that acts autonomously, in a distributed way, in real time. Oil and gas enterprise-wide optimization system integrates mathematical models for each of oil and gas's supply chain links, so that supply chain planning is managed with a holistic view. At the level of industrial facilities, the oil and gas chain involves connection between industrial facilities, using multimodal transport systems. Based on the models to be integrated, and considering the magnitude, and the association between them, it is considered that the hypothalamus of a refinery business should be made up of 5 subsystems. Oil refining and petrochemical. Refinery industrial services. Water treatment. Multimode transport, and financial and fiscal. Now, if you look at each business from the point of view of functionalities, you have an artificial brain made up of multiple models, associated with the problems of the administrative functions of each industrial plant. It generates another brain of the same problem. Artificial brains can share models such as production, where the sales and operation planning model belongs to the brain of systems and the brain of functions. In the same way, the models can share math problems, and the problems can share equations. Construction of artificial brains. The methodology for building an artificial brain follows a formal modular process, which High calls structured mathematical modeling. First, all mathematical equations, and their components, are stored in a relational database, part of an artificial hippocampus, which can be handled using SQL, standard query language. This implies an open and standardized structure, which is not common in mathematical modeling. Sets of constraints form problems, called by High, mathematical artificial neurons, and sets of problems form models, and a set of models forms an artificial hypothalamus, which is linked to the corresponding artificial cortex, a network of mathematical artificial neurons, and the artificial hippocampus, memory, which stores, in addition to mathematical formulations, the history of all model runs. From the concept of enterprise optimization, it evolved towards enterprise-wide optimization, which implies expanding the coverage of the decision support system, which High calls enterprise-wide optimization systems. Visually, it is easy to see the evolution of the IBP concept to AWO, which covers all operational functions of an industrial organization. This leads us to two problems that must be solved from a computational point of view. If traditional approaches are used, many programmers are required to generate all the source code needed to develop and coordinate all models, and it takes a lot of computational power to solve the built-in problem. In order to solve this situation, High has developed OptX, Optimization Expert System, a generative artificial intelligence, which is responsible for producing all the source code required by an artificial brain, using large-scale optimization methodologies to solve complex high-dimensional problems. The diagram presents an artificial hypothalamus of an IBP process. Those interested in learning more about artificial brains are invited to read the white paper. Oil and gas artificial brains. Case pipelines transportation, which is part of the course material. Hypothalamus artificial intelligence brings real-world oil and gas business optimization practice to academia to teach enterprise-wide optimization systems implementation. The image presents the main topics that will be covered in the course. These are divided into fundamentals and use cases. Use cases are related to solving a real-world math problem solved by High or for other institutions. In several cases, the programs used to solve the problems are presented and analyzed. Below are different topics that the course covers. Oil and gas production optimization. Integrates reservoir behavior as part of the optimization model, considers four fundamental aspects: production system, reservoir behavior, operating modes of wells, and flow in the hydraulic system. The image presents the main models associated with the production of oil and gas. The objectives of optimization models depend on the planning horizon, and can be divided into real-time, advanced control, scheduling, short-term production optimization, planning, medium-term field optimization, strategic operations planning, long-term planning, reservoir recovering optimization, and strategic investment planning, portfolio optimization in oil exploration and production. The diagram summarizes the connectivity of the mathematical elements that allow modeling the well, in the aspects related to the pressure and flow of hydrocarbons, along the hydraulic system that is part of the production system. Operations planning integrates multiple fields, which in turn comprise multiple oil or gas, which are operated by means of multi-well interconnected. Interconnection, which occurs at the surface facilities, allows gas and oil can be sent to storage for subsequent release through a transport system. The goal of optimization is to determine the contribution of each well, to meet demand while minimizing the total cost of the operation during the planning horizon, which is associated with energy consumption in the production system, more investment in adaptation of deposits when this restructuring of the productive system topology is allowed in the model. Smart grids, flue gas and hydrogen production, in oil and gas fields, are new activities that need to be optimized in the oil industry. Oil transport, trading and blending optimization corresponds to a dynamic model that optimizes oil distribution between fields, refineries and ports, the oil mix for use in refineries, the mixture of oil for export in accordance with quality standards and established supply contracts, import of oil according to offers in the spot global oil market, and import/export of oil according to offers in the oil derivatives financial instruments. Oil transport, trading and blending optimization corresponds to a dynamic model that optimizes oil distribution between fields, refineries and ports, the oil mix for use in refineries, the mixture of oil for export in accordance with quality standards, and established supply contracts, import of oil according to offers in the spot global oil market, and import and export of oil according to offers in the oil derivatives financial instruments. Pipelines planning and scheduling. The image presents the main models associated with the transport of oil and gas. Piping systems require at least 3 models to coordinate their operation. S&OP, tactical planning, on the order of months, weeks, SCH, daily operation scheduling, such as tenders planning, and RT, real-time, on the order of hours. Under the principle of transitivity of algebraic formulations, models grow in complexity, as they descend from the hierarchy of decisions. All models share equations, mainly those related to the physical process. Therefore, they can be made in a continuous modeling process. The models of higher hierarchy will be more aggregated, in order to cover long periods of analysis, of the order of the years. The emphasis of the model should include the interpretation of the economic and technological future, so it is appropriate that they are stochastic optimized. As the models approach real time, the level of detail increases, and the planning period decreases, the most important being the engineering representation of the process. Those interested in knowing the topics to learn in this part, Hi invites them to watch the video. Oil pipelines companies, enterprise-wide optimization systems. Oil transport systems optimization corresponds to a general model, common to all types of oil products, raw, refined, natural gas and biomass, which represents the process for a specific system, including particular equations when this is required. It considers 2 types of transport modes: pipes and multimodal vehicle, like vessels, barges, train tanks, and/or trucks tanks. Kalman filter applications. Prognostic and health management, PHM, maintenance in pipelines. Those interested in learning more about these applications are invited to watch the video. Kalman filter applications in oil and gas pipeline systems. Homeland security. Case, defending critical infrastructure in pipeline systems. Those interested in delving deeper into this topic are invited to watch the video. Homeland security defending oil and gas critical infrastructure. The video is based on the paper Defending Critical Infrastructure. Critical infrastructure protection. Development of tools to anticipate, identify, and measure the risks to which a nation or region's critical infrastructure is exposed. This is to reduce the risks and consequences of an attack. B-level and tri-level optimization models to make critical infrastructure more resilient against terrorist attacks are used. Each model features an intelligent attacker, terrorists, and a defender, us, information transparency, and sequential actions by attacker and defender. 3 real examples are presented. The U.S. Strategic Petroleum Reserve, the U.S. Border Patrol at Yuma, Arizona, and an electrical transmission system. Each exercise gathers open-source data on a real-world infrastructure system, develops an appropriate B-level or tri-level model, and uses these to identify vulnerabilities in the system, or to plan an optimal defense. Oil refining optimization includes a generic model that can serve interchangeably to plan the crude and/or biomass refining processes that may be spatially detailed in all units used in the production of refined products. The image shows the main models associated with the operations in the oil refining and petrochemical plants. Those interested in knowing the topics to learn in this part, Hi invites them to watch the video. Enterprise-wide optimization in process industries. Case, oil refining. Mathematical models. The central process of tactical optimization of production and energy management is related to the integration of the 2 systems, through integrated mathematical modeling. These services often include self-generation, cogeneration and the exchange of energy with the interconnected electricity system. The objective of the model is to minimize the consumption,
or cost, of the energy required by the industrial processes, supported by the industrial services plants. The industrial services system is coupled with the production process model to holistically optimize the transformation of crude oil into refined products.
The simultaneous optimization of both industrial production and energy conversion is related to polluting emissions of gases and liquids, associated with increasingly demanding environmental control laws. HI may integrate complex industrial process models to redesign the power supply system, according to the new power technologies. This type of model includes the simulation of polluting processes to determine the optimal mixture of fuels, in accordance with environmental regulations. Water consumption minimization in industrial complexes. Natural gas supply chain optimization. Those interested in learning more about this topic can watch the video. Use case: Oil Express Natural Gas Field Exploitation Planning. Maintenance of oil and gas assets. The mathematical models required to carry out this work can be classified into two types: models for optimization of maintenance activities, and models to support the general maintenance management. The maintenance of industrial plants, associated with production plants, or process units, that make up the large industrial facilities. These processes may involve shutdown of plants/units, or duration of production leading to a decrease in the productivity of the industrial asset. Those interested in learning more about this topic can watch the video. PHM, Prognostics Health Management. Optimal maintenance of industrial asset networks. Land distribution of oil products and coordination of inventories in regional storage systems. The image shows the main models associated with the distribution of oil products. SAND-OP and ALM, integration of production, finance, and taxation models. Enterprise risk management, ETRM. The idea behind ETRM is that an organization's, while it can't eliminate risks, it can manage the risk. ETRM is a scientific approach to shaping risk, which is based on trading research methods such as applied probability and statistics, stochastic simulation, and investment portfolio optimization. In the case of integration of production and finance, there are originally two models, S&OP and ALM. These models can be summed, resulting in a mathematical model containing the constraints of the two models, forming the S&OP ALM model. The user will have three models, the original ones and the integrated model. The integration process can be conceived as the S&OP model that generates results, production and sales, which must be transformed into financial results, in the ALM model, in such a way that the financial statements of the organization are produced, the control of which is the true objective of a private company. The traditional thing is to coordinate the two models, in such a way that the productive model feeds the financial model. This process has no feedback, and therefore the financial model can be a workbook in Excel. The modern vision is to integrate the two models into a single model, which has significant advantages. It's a feedback model between the two systems. The field of control is expanded, as it is possible to introduce financial constraints into the production model, for example, cash flow constraints. Financial variables can be entered as part of the target function, e.g., the value of the firm at the end of the planning horizon, and achieve optimal solutions, which are not obtained with the coordination of models. Theme plan. The table summarizes the plan of topics to be discussed. Continuation of the previous table. General conditions. RCADT and/or HI issues a certificate signed by the scientific coordinator, for which the student must participate in at least 20 conversation sessions. The price of the course is $1,000. Student discounts are offered as follows: 50% to undergraduate students, and 20% to master's students. The course may be taught under the in-company modality. In this case, prices vary depending on the number of students. Companies, public bodies, universities and research centers are considered. In the case of professional and trade associations, research centers and universities, HI proposes bilateral agreements analyzing each specific case. In university courses, For academic institutions, this course is an opportunity to modernize their operations research courses according to the state of the art, updating professors at the level of doctoral knowledge, implement postgraduate courses in their institutions, with the help of an in-house professor dedicated to this purpose. Access the know-how of real-world application, and truly leverage digital, high-level, AI-powered education. Economic agreements have special conditions with the aim of promoting advanced knowledge in developing countries. Projects. The value of the advice on a project will be between $500 to $1,500 per semester of the duration of the consultancy. The value will be defined once the student submits the project proposal. Taxation. The above values do not include withholding tax and value-added tax. If necessary, these amounts must be charged to the value of the course in such a way that the net payment is equal to the stated rate. Payments via PayPal or similar have a surcharge of 10%. Specific conditions. Academic inquiries are made directly to the Scientific Directorate, and special agreements and administrative consultations are carried out with the Administrative Directorate. R-CADT invites you to learn about other courses in advanced analytics and mathematical programming. Courses for the energy and mining industry. Electrical sector, systems and wholesale market, renewable energies and smart grids, oil and gas, and mining and metallurgy. For the industry in general, industrial production, bioindustrial production, marketing and sales, and transport and logistics. For more information you can write to the email that appears on the screen. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." The importance of this phrase lies in the fact that all modern mathematics is based on algebraic models that become algorithms, that use all the power of current computer technologies. Thank you for your attention.